considered everything.
Okay, thank you for the invitation. We have covered a lot of ground today, and so on. And I want to shed a few or share with you a few perspectives which are in this process mitigating climate change and strategies how to deal with it. You know, how you may look at it nowadays, you know. And one of the things is, you know, I put in front this old Latin proverb, which says, quid agis prudenta agas et respice finem. You know, that's something which I must say, which is, and for those who don't share Latin, you know, whatever you do it wisely and consider the final outcome. And in the face of climate change, you know, we need to analyze, understand, and also communicate, because to deal with climate change is not only as Augusto has already pointed out in the beginning, it's not only an individual task, it's something which needs to be dealt with the human population as a total, you know, and we need to develop strategies and countermeasures and actions. And there is one problem with the whole thing. You know, in human science, we are breaking such climate change as a complex problem. We are breaking it down into smaller sub-problems to deal, and necessarily and always, you know, it comes together with simplification, you know. And you have already heard it say, you know, what is in the what is what are the themes in climate change? You know, first of all, everybody is looking at CO2. We heard about carbon sequestration. We hear in public discussion about decarbonization, reduction of CO2 emissions, you know, then adaptation measures for climate change. We need also to deal with human mobility, and very often we hear energy from renewables, you know. But I would like to add a few aspects, and these are the ones which are not, you know, immediately dealt with when we look at the above word rape, you know. It's water vapor and albedo, you know, which are also related to climate change. Albedo comes sometimes also into play when we talk about land use change, and so on, because albedo is also linked to these things, and it's also a contributor to climate change and so on. So let me deal with these two aspects: water vapor and albedo. You know, water vapor as oh, that was too fast. We have to go back. This one is the one I want to show. You see, when we look at the you know, the greenhouse gas, the greenhouse effect in the atmosphere, we hear predominantly about CO2. You know, you see here, this is the absorption spectrum of CO2, and you see quite some bands, you know, especially in the near infrared and so on, and also the farther infrared. That's CO2. But very often it's overlooked. Let me go back. It's overlooked that we have another powerful greenhouse gas, which is water vapor, and which is very often linked with some strategies and some activities to deal also with mitigating the climate change effects and so on. Water vapor is for sure one thing, you know, which is, you know, not as important, seen as not as important as CO2, but it's always, you know, going in sequence with CO2, you know, and we see it that, for instance, when it comes to you know, uh, global warming, water vapor may also play an important role, despite of the fact that water vapor is not as long-lived. You know, or everybody is concentrating on the very long-lived CO2, but not so much on water vapor. But we see the effect. You know, when it comes, for instance, to nighttime cooling, radiative cooling. You know, you know that, for instance, the nighttime cooling in a desert environment is much more pronounced than when we go into a humid environment, because water vapor is trapping also long wave radiation, you know, and water vapor, and we may deal with this water vapor and may find a few other aspects which are very important and which have climatic effects. Water vapor, for instance, is effective when it comes to dew formation. Nighttime cooling may not be as pronounced, for instance, when we get during the late night hours, when we get dew formation. Condensation energy is released, and we don't get this type of cooling as we get them, for instance, in a desert environment where we have little water vapor and where we don't encounter dew formation. And further on, let me deal with a few other aspects of water vapor which are quite important for climatic change, you know. Water vapor is not only a powerful greenhouse gas, which its lifetime is only weeks, while CO2 has a lifetime of decennia. But water vapor content is exponentially related to temperature. As the temperature is increasing, the carrying capacity of the atmosphere for water vapor is also tremendously exponentially increasing, you know. And we must not overlook that other than CO2, you know, CO2 is not changing its states, you know. The change of state for water vapor is a very powerful energetic process. You know, 1 gram of water vapor means that 2,500 joules are consumed to evaporate this water approximately. Yes, and this amount of water, of energy, is in the atmosphere, and it can be transported. 1 gram of water vapor is a minute component, you know. And if you transport 1 gram of water vapor from A to B, you are transporting 2,500 joules, which may be released on condensation process again. And to show you the value of these things, this would be the equivalent. This amount of energy is equivalent, you know, to transport 3 cubic meters of air, and which have been warmed by 1 Kelvin, you know. 3 cubic meters of air, warming them by 1 Kelvin, contain the same amount of energy than 1 gram of water vapor. And you know, you see that this especially this very powerful medium of transporting energy, you know, is also, and you have the indicators in nowadays weather phenomena which occur under climatic change, you know, the violent energetics of storms, you know. We see in many, for instance, in the areas where you have the hurricane or the typhoon alleys, you know, we see that the frequency of the storms has increased, and also the destruction and the energy which is released during the storms has become more and more violent. So let me share with you this idea that water vapor is not something we should overlook and put aside, you know, because it's such a greenhouse gas which is only of short lifetime. You see, there are quite some climatic important issues linked with water vapor. Don't underestimate water vapor and its climatically exchange. And especially, you know, when it comes also to alternative fuels, you know, I have heard some Austrians talking about hydrogen as a beautiful fuel where we can, through fuel cells, we can solve all our mobility problems, you know. But you must imagine that, for instance, if you burn hydrogen, you know, you are creating water vapor again, and you are releasing water vapor to the atmosphere. Yes, so don't underestimate these things. And you know, this is one of these reductionist thinkings when it comes to deal with mitigation processes. Yes, and I come further on to the albedo reflectivity glitch. You know, albedo is a measure for the reflective percentage of solar radiation, and it is linked to land use and land surface property, and it's decisive for the energy balance of the system, you know. And last not least, it also links with climate change. Yes, and let's see some of these mitigation processes we are proposing and how the albedo glitch links to these things, you know. For instance, what activities to mitigate climate change is sequester more carbon in humus. But we have already seen with the pictures of Ines, you know, we have seen a humic soil is a darker soil. And the darker soil means a lower albedo, you know, and usually dark soils have a reflection which is 10% or more less than the reflection of a not so humus containing soil. And this means there are 10 or more % of the daily solar radiation are turned over into heat, and this heat will go into the energy balance of the location. And other than being reflected solar radiation, so reflected solar radiation can pass through the atmosphere and leave our system. You know, it does not contribute to the greenhouse effect. You know, it's the solar radiation which is directly reflected is passing through the atmosphere, and it's not converted into heat and infrared radiation. So that's the problem. Yes. Then the next thing, another glitch which links to albedo, sequester more carbon through afforestation. Here we come again into this albedo problem. You know, the albedo of forest, you know, as we find them in literature, is between 5 and 15%. A field or a meadow, you know, has an albedo of 15 to 30%, you know. So there are 15 to 15% to 0 to 15% more energy, more solar energy is directly reflected when we deal with a normal field or meadow as compared to a forest. Amongst forests, there is also a difference. You know, if you have, for instance, if you have a conifer forest, you know, the conifer forest will have a lower albedo than the broadleaf forest. So we must also think about these things, that we up to 15% of solar radiation may be reflected from a normal field, and even more may be reflected if we think about some of these savanna or desert systems. And here we come also to this conversion for agriculture, for instance, for irrigation agriculture, that we irrigate semi-arid regions of the world. Yes, and we create green fields there, you know, which absorb much more energy and turn it over into heat and evaporation of water and so on, which feed into our climate system immediately, you know, and are not reflected without harming the climate system as direct reflected solar radiation. Yes, and I'm already coming to this point, you know, of irrigation, you know, irrigating fields mean, on the other hand, especially when we do sprinkler irrigation, or as we see nowadays, for instance, we sprinkle also in the city environment, we sprinkle water and evaporate water to diminish the high temperature, the urban heat island, you know. It's something which is, when we have hot weather in Vienna, it's practiced there that, for instance, they are sprinkling or nebulizing water, and this is immediately, you know, evaporated. We have a cooling effect. But on the other hand, we are releasing again a lot of water vapor, and water vapor is very energetic substance. We are releasing it to the atmosphere. Yes, and last not least, we must not overlook that wet surfaces, you know, when we have a wet surface compared to a dry surface, you know, already my former professor, she investigated the albedo effects of wet versus dry surfaces. And she comes up with 5 to 10% more more absorption of solar radiation when the surface is wet. So again, think about this, more radiation is consumed at the surface and is turned over into the climatic and energetic cycle, you know. And last not least, you know, renewables. We are sometimes talking also about the application of photovoltaics, you know, this is renewable. But also we must think photovoltaics are also land surface, and they have the albedo, you know. And if you have seen a photovoltaic panel, you know, it's very dark. According to the literature source I have given you here, you know, the albedo of a photovoltaic panel is less than 10%. 10% and less than 10% of the incident solar radiation is directly reflected. And I give you this example, you know, for a summer day in mid latitudes like Central Europe, we can assume that the solar radiation amounts to 1,000 watts per square meter. And if we take this 1,000 watts per square meter, the solar panel consumes 900 watts per square meter. And of these 900 watts, there is a conversion of 17% into electricity. So 153 watts per square meter go into electricity, but 747 watts per square meter are going into heat, you know, heat which is created and which is again circulated in our environment, and which is also contributing to climate change. Yes, so these are the aspects I want to put into your perspective, so that we don't only concentrate on carbon and carbon sequestration and these things and the renewables, and we have linked it. You know, everything we do has its environmental impact. Yes, but my conclusions are, is everything in vain? No. But we need to think holistic, and we need not to be over enthusiastic, you know, by sequestering another ton of carbon. You know, we need to think holistic. We need to think also and develop wise use of energy and resources. Think about this, that saving energy and saving resources is also contributing, and I think it's one of the most important contributions towards mitigating climate change, because all human activities have an environmental impact. And that's what the message that what I want to give to you. Thank you for your attention.